These are the most frequently asked questions in Algebra 2 for section 3.1. Usually has to do with the word problems here. So number 13 says, a store sells small notebooks for $8 and large notebooks for $10. If you buy 6 notebooks and spend $56, how many of each size notebook did you buy? Well, as I said to you before, I'm looking for totals when I look at a problem, and I see this $56 right here. And I realized that $56 didn't come out of thin air. It came from spending money on the small and large notebooks. So I'm just going to have X be the small notebooks, and then Y will be the large notebooks. And since this equation involves $56, the rest of the equation needs to be about money. So I know it's $8 per small notebook, plus it will be $10 per large notebook. And so that entire equation is about money. Now if you take a second look at this problem, you realize there is another total, and that is the 6. So then it's a matter of figuring out, okay, how do I get an equation out of that? Well, it says you're buying 6 notebooks. So the question becomes, well, how many of each type? That's what we're trying to figure out. We don't know, but we know you're going to buy some of each. So you're going to have some small and you're going to have some large. And then at this point, you would go ahead and solve these for Y so that you could plug these into your calculator. And the top equation is going to become Y equals a negative 0.8x plus 5.6. And we can change this one into a decimal because we're talking money, so that certainly is understandable. And then the green equation will become Y equals negative x plus 6. And from there, I know you can get the rest of it. So you plug those into your calculator and you're going to find the intersection of those two, and that will give you your answer for number 13. Then the next one that I thought people would ask about is number 15. And this problem is one where I'm going to have to put my calculator up here so that you can see that. And it'll probably take me a little while to get all this data in here, but it's going to be worth it in the end. So what I had decided to do was use 1970 as my 0 year. So I'm going to go under Stats, Edit, and in this first one for 1970 I'm going to put 0 because that's my 0 year. And then each one of those from 1970 to 1975, that will be 5 years. From 1970 to 1980, that will be 10 years. And these are just going in intervals of 5, all the way up to 2000, which would be 30 years later. So I have all of those in there. That takes care of my X's. So my X's were all about those years. All right. 30 in, right arrow, and now what I want to do is I want to put in the men. So men were 67.1, 68.8, 70.0, which the calculator will just turn into 70 anyway, 71.1, 71.8, 72.5, and 74.3. And no, well, see, now it's helping me and telling me that something didn't get punched in right there. I'm guessing it didn't take one of my enters. So let me go back and fix that. Yep. So after 71.8, I have 72.5. Make sure it takes the enter this time, and 74.3. All right, and again, I see that they match up, which is a big part of checking. Now that third list, I'm going to go ahead and put the data for women in there. So 74.7, 76.6, 77.4, 78.2, 78.8, 78.9, and 79.7. All right, and all is matched up. So now what I need to do is get the calculator to do that linear regression for me so I have an equation for the line. So I'm going to hit Stats, arrow to the right once for Calculate, and number 4. And here's where I tell it not only which lists I want it to use, but where I want it to store it. So I'm going to hit second, number 1, to tell it list 1. Then I need to hit the comma. And I want to use list 2 for the men first. And I want it to store that in y sub 1. So variables, y variables, arrow to the right once. Number 1 for functions, and number 1 for y sub 1. And now when I hit enter, not only does it give me the linear regression equation that I need to write down for the problem, but it's also going to store that in y sub 1 for me. Now I need to do linear regression again, so stats, calculate number 4. This time I want those same x values, so that's still going to be in list 1, but I want the women's y values, which I stored in list 3. And I want the calculator to do the linear regression and then put it into y sub 2. So variables, y variables for functions, and y sub 2. And I hit enter. And again, there's the other equation I needed for the linear regression. Now if I go into y equals, they're both stored in there, and I didn't have to do any of the typing, which is kind of nice because those were kind of obnoxious decimals in some of that. So then I go to my window, and I start thinking about what this was standing for. And X stood for years. And this started in 1970. They gave it to me over a 30-year span. I think I'll just take a chance here and say something like 150 years. So from 0 to 150. And then the Y values all involved age in years here. So, let's see, I can't imagine we're looking at anybody that's more than 100 years old, so let's go to 100 there. All right, and then we hit graph. And we do see the intersection, so we'll hit second, trace, number 5, and then enter 3 times because I only have 2 lines up there. I don't need to worry about telling it which ones. And that tells me it's going to be another 114 years before the life expectancies for both match at about 93 years old. So this started in 1970, and I need to add 114 years to it. And when you do that addition, you get, it's going to be around 2084 that they would expect to see the life expectancy for men and women to both be the same. So that one, very, very calculator oriented. Then the next one on my list was number 41. And this one is talking about how you and a friend are both reading a book. You read 2 pages each minute, and you've already read 55 pages. Your friend reads 3 pages each minute and has already read 35 pages. And we're supposed to graph and solve a system of equations to find when you will have read the same amount of pages. And as we get to the end of it here, it says, let X represent the number of minutes it takes to read Y pages. So Y is your total. Y is the total. It says you read 2 pages a minute, and you've already read 55 pages. So you're at 55, and you're going to continue to read, so you're going to increase your number of pages by 2 per minute. And we want another total for your friend. And your friend has already read 35 pages. They're going to continue to read. Apparently they read a little faster. 3 pages per minute. And then, again, what we want to do with this is grab a calculator and find that intersection. So probably the most challenging part of that is just getting your window to be correct. So, you go in here and clear out all that lovely work from the last problem. And we had those already solved for y. So all I have to do is punch those in, 55 plus 2x. And then the next one is 35 plus 3x. But again, I need to think about my window a little bit. So 0 was talking through how many minutes here. And, well, it's a book. We'll try 100 minutes there and see if that'll take care of it. And then the number of pages, well, I'm guessing 300-page book. And we hit graph. And there it is. And sure enough, we can see the intersection. So second, trace. Number 5, it's the only 2 lines I have stored in there, so I'm just going to hit enter 3 times. And that would be with x being 20 minutes, you will have both read 95 pages. So again, it's getting the equations set up. That's probably going to be the biggest trouble for most people, but I just wanted to make sure that you have an example to go by of putting it into the calculator, just in case that's the area where you're struggling. Number 42 says you can choose between 2 tennis courts at 2 university campuses to learn how to play tennis. One campus charges $25 per hour. The other charges $20 per hour plus a one-time registration fee of $10. So we have 2 campuses here, and we're looking for totals at both of those. And the first campus is $25 per hour. And I'm going to have X stand for my hours here. And then Y is the cost. Because remember, when we're talking about a total and a word problem involving money, it's the total amount of money we're going to spend. The other campus charges $20 per hour, plus, there's more, a one-time registration fee of $10. So A says, write a system of equations to represent the cost C for H hours of court use. All right, so that means they didn't want my Y and my X, but I have my key here so I can see what I need to do. So they want C equals 25H and C equals 20H plus 10 using C and H. And then B says, when would they cost the same? So you're going to put those into the calculator and figure out. Go ahead and do that up here. Back to the calculator, clearing out the last problem. And we had $25 per hour. And then the other one was $20 per hour plus the one-time fee of $10. All right, so window. Well, again, 100 hours. I mean, that's a lot of tennis to play. Maybe I'll go with 50 hours this time. And the cost, well, $20 an hour and $25 an hour. $300 is not out of the question. So I'm just going to hit graph and see if I can find that intersection. And it turns out the intersection is right in the corner there. So I'm going to get a better look at it. Like I said before, the calculator will find it for me, but I'd like a better look. So I'm just going to change that from 0 to 10 and get a very different look at this. And now it's too close. You know, I have a lot of white space on the X's here, so I don't need all of those X's. But I did want a few more of those Y's back to take a better look at. All right, Now, like I said, we can see the intersection, so I'm going to go ahead and let the calculator do its job. As long as we can see it, it'll find it. And it's telling me that that intersection is at 2 and 50. So 2 hours, and they'll be paying $50 at either one of those. So that would be the answer you'll use for Part B. Then C says, if you want to practice for 10 hours, which campus should you choose? This is the one time when we really like the table feature. So what we want to see is, when we get at the point of playing tennis for 10 hours, which one is cheaper? And it turns out that y sub 2 is cheaper. And that was the equation with the membership fee. So that would be the one that we would want to choose. And again, you can just use the table feature to see that. You can definitely see that the $25 per hour court is going to cost you $250, while the membership fee plan is going to have you at $210, which is cheaper. So once you get those set up, I think it's probably going to go much better. So let's talk about some of the questions that are maybe a little tougher because they're more abstract. And that would be problems like number 44. It says, is it possible for an inconsistent linear system? Remember, inconsistent means the lines are parallel, and we don't like that because then we have to put no solution. And in math, we always want to have an answer for things. We want an exact answer. So an inconsistent, we're talking about parallel linear systems. We don't get an answer. Is it possible for that to contain two lines with the same y-intercept? So we're talking about two lines that are parallel. Let me just go ahead and make an example of a couple of parallel lines here. So there's my first line and there's my second line. And is it possible for us to get no solutions if they both have the same b value back here? In fact, let me just throw a number in there. Let's say these were both 3. Well, quickly you realize then they're going to be the same line. And if they're the same line, then it's consistent. You know, we do get an answer. It's all real numbers, or it's just not going to be possible for them to be parallel. So again, the whole key here was that if it's inconsistent, we're talking about them being parallel, and then there would be no solutions. However, if they have to have the same y-intercept, then that means we're talking about the same line, which is infinitely many solutions. It is consistent and it is dependent. So the answer would be no. They would be the same line. And there it is. Then we had some others that were similar in being kind of abstract, which involved this reasoning here. It says, determine whether each statement is always, sometimes, or never true for the following system. And 46 says if m equals 1. So we have y equals x plus 3. And then y equals 1x plus b. If m equals 1, the system has no solution. So what we want to do is think about the fact that, well, they have the same slope. So if they have the same slope, we want to just jump to the fact that, hey, they're going to be parallel. But wait a minute. They might have the same slope, and they might have the same b value. Because if somebody comes along and says, now b is 3, then they might be the same line. So this is a lot of the times, yes, but every once in a while, no. So we're going to have to put a sometimes up for this. Sometimes they're parallel and we get no solution, but sometimes it's the same line and we have infinitely many solutions, and those are definitely on either ends of the spectrum there, no solutions and infinitely many. 47 says, now go back and look at the original. Here's y equals x plus 3. And what if b is 3? So it's y equals mx plus 3. It says if b equals 3, the system has exactly one solution. So if this is the case, we need to think through what's going to happen here. they didn't give us the slope for number 47. So if the slope is not the same, if m is not equal to 1, well then we'll get one solution. Yep, that'll work. But the problem is, m could be 1. There's nothing in this information that tells us that m isn't going to be 1. So it very well could be, and then we'd get no solutions. So this is another sometimes here. Depends on the other variable that we're working with. And then 48 says, if m is not equal to 1, the system has no solution. So no matter what they're saying, that can't equal 1. Well, if that can't equal 1, there is absolutely no way that these lines are going to be parallel. And if they can't be parallel, they will never get no solution. So this is going to be a never. Can't happen with a slope of 1. And 49 says if m is not 1 and b is 2, so I'm just going to change this right here. The system has infinitely many solutions. Well, with number 49, as we look at it, we're saying the only way it's going to have infinitely many solutions is if they're the same line. It already can't be the same line because they told us that the slope cannot equal 1. So if the slope can't equal 1, there's no way that these are going to be the same lines because the first one, the first equation that we have, has a slope of 1. So this can never happen. It can never happen. All right, I think that should take care of the pieces that were troubling you from section 3.1.